Okay. Okay. Bismillah ar-Rahman ar-Rahim. Okay. So last time we stopped at the reactions of alkanes, right? We discussed combustion, substitution, and okay. And then we were talking about, yeah, so hydrogenation and hydration were left. Right. We were discussing the reactions of alkenes, right? We had already discussed alkanes, if I'm not mistaken. Okay, there were a few points that I forgot to mention in the last class. Can you get me a notebook, notepad for explanation? Okay, in the last class, I missed a few points. When we were, okay, let me start with this. Okay, there's a question. Which is more reactive, alkanes or alkenes? Did we do this?
Alkene.
Oh, okay, alkenes, and that was because of the
Double bond.
right? I think we have discussed that. Okay, let's move on. Then, what does branching do to the boiling and the melting point of hydrocarbons? Does it increase or decrease branching?
Decrease.
Decrease, and the reason is? And the reason is? In one word, one
room for
sentence.
contact.
Sorry, I cannot hear you well. Wait. Can you repeat?
There is not much contact between. So
Yeah, the examiner will be looking for key terms in your answer. So you will say there are more van der Waals interaction, van der Waals intermolecular forces between the molecules. Okay, you won't say attraction or repulsion, just leave that because they can be both depending upon which part of molecules are interacting. Okay, so you will just say that there are more van der Waals interaction between the molecules, right? So more the interactions, higher the boiling and the melting point. Okay. Okay, now when we were naming the molecules in our last class, I forgot to mention that, please mute yourself, kindly mute yourself. So the name has two parts, right? The last name and the first name. And so last name depends upon the family. And then the first part, if it's a simple hydrocarbon chain, will be the number of carbon atoms. And if you have substituents attached, substituents can be halogens or they can be another chain of hydrocarbon. Now, if the substituent is another chain of hydrocarbon, then the point that I forgot to mention is, for example, this. We were trying to, for example, this is the hydrocarbon we are trying to name. So this is the longest chain, right? Whether we count it this way or this way, both the cases it's propane. So it will be propane. And then if we start counting the carbons, this is branch. If I take this to be the parent chain and this the branch, then this group is on the second carbon of the parent chain, right? So I will write 2-methyl. So the point that I want to mention here is that in the substituent, the substituent suffix or end name or the substituent's name will end in YL. Substituent's name will end in YL. Okay, so and this is only when the substituent is a hydrocarbon. But if you have a halogen, for example, if this was, let's say bromine, or if it was, let's say chlorine, then that halogen's name ending with O, chloro, fluoro, if it's fluorine, or bromo, okay, if it's iodine, iodo, like that. Okay, so these are the, I can share the IUPAC rules of naming compounds. Okay, you can just go through them. No need to learn, but go through them. It will give you an idea. So you will feel confident about naming the compound. Sometimes they name the compound and they will ask you to draw its structural formula. Yeah, I mean, it can go the other way around as well. Okay, so these were the points I had missed and I wanted to mention now. Okay. Okay, what were the reactions? What are the reactions that alkenes and alkenes can undergo? Can we name them? Let's list the names of the reactions that alkanes and alkenes can undergo. Can you name a few reactions?
Substitution reaction.
Okay, good. Very good. Substitution, combustion. Yes, two and more.
Addition reaction.
Very good, very good. Substitution, combustion, addition. Very good. And are there more?
Bromination.
Sorry?
Bromination.
Yeah, bromination is an example of addition. It's a type of addition reaction. So bromination meaning addition of bromine. So yeah. So yes, I think these are the three basic types. So we have addition, combustion, and
Substitution.
yeah, substitution. And yes, one we forgot, redox reactions. Redox reactions, reduction, and oxidation. Okay, so there are 4 kinds of reactions that are included in your course, I think. I don't know if they participate in more reaction. I don't remember, but these are the 4 you have to deal with. Okay, so bromination is a type of addition reaction. And then hydrogenation is also an example of addition reaction, which is the addition of hydrogen atoms. Okay, we will discuss. And then hydration. Don't get confused between hydrogenation and hydration. What's the difference?
One is the addition of hydrogen and the other is the addition of water.
Right. So hydra, the word hydra is Latin. It means water. Okay. No, I think, okay, I'm not sure about that, but hydration, it has to do with water. Okay. Hydrogenation is addition of hydrogen molecule. Okay. We will discuss these two. And so, but before I move on to hydrogenation, I want to talk about addition reaction of halogens, like bromination. You can have chlorination, you can have fluorination, you can have iodination. So basically you can add any of the halogens you can add. But my question is, of these halogens, which ones do you think will more readily get added to an alkene? This should be alkene. Which one will more readily, I mean, which of these halogens will react more readily with an alkene as you go down the group? Any guesses? I'll give you a hint. What happens to the reactivity of halogens as you go down the group?
They decrease.
Decreases, right? So the more reactive halogen is this.
Fluorine.
Right. Why is this more reactive? Because see, they are non-metals. In order to react, they have to accept an electron. So the smaller this radius of the atom, the closer the nucleus is to the neighboring coming reactant molecule, or you can say that, yeah, it is closer to its outermost shell. And so it's easier for it to pull an electron, from its reactant. So therefore, fluorine is most reactive, and therefore fluorine will react most readily with the alkenes. Okay, as you go down you can say the rate of reaction, I mean, not the rate of reaction, but they will require more energy to react with the alkenes. The activation energy will increase, so you'll have to put in more energy. Okay, so that was that. So let's move on to hydrogenation. Okay. Now it's helpful if you make structural formulae of these molecules and then try to understand. This is what I like about organic chemistry, because structural formulae are easy to make, easy to understand, and you can actually see which atom is going where, right? So you have this ethene, okay? Why is it called ethene? Because it has 2 carbon atoms and it belongs to the alkene group. So this is the structural formula of ethene. Okay, everybody knows how to draw a structural formula, right?
Yes.
Yes. Yes.
Yes. So you just have to make sure that each carbon atom has 4 bonds and hydrogen should have only 1, right? Now, ethene hydrogenation, that means addition of hydrogen. Hydrogen molecule we know is diatomic, okay? And all of them are in gaseous state. We're dealing with all gases. Why are they all gases? Why are they all gases? Real quick. जोर से बोल लो बेटा.
Because they're an
Boiling point is-
exothermic reaction.
Yes, very good. Sundas answered boiling point is less than the room temperature. Okay, so that's why they are gases. Okay, yes, that exothermic, that thing was in combustion, but they, I mean, alkanes and alkenes, these hydrocarbons, their boiling point usually is less than the room temperature. Okay, until and unless their molecule is very, very big. So we're dealing with ethene. It has only 2 carbon atoms. So molecular weight is not that much. Okay, so that is why. Okay, so now you can see that this reaction takes place at such high temperature, 150 to 300 degrees Celsius. That means this is not a spontaneous. A spontaneous, remember, what's a spontaneous reaction? That
Reacting quick.
that takes place on its own, without any heating, without any catalyst, without any help from you. It just takes place on its own. So this is not spontaneous. It requires so much heating. This is not spontaneous, and it also needs a catalyst. Remember what was a catalyst? Can somebody?
Of the chemical
It is a
reaction.
substance that increases the rate of reaction, speeds up the rate of reaction.
Right, and more specifically, it decreases the activation energy required for a reaction so that your reaction can take place easily, right? And so in biological, in organisms, we have what as catalysts? We have
Enzyme.
enzymes, right. But here this is not an organism. I mean, this is taking place outside, I mean, in industries, maybe in factories. And so this process is, by the way, used in factories in making of margarines, butters, animal fats, and also found in animal fats, and in making of creams. And I will tell you later, I'm coming to that point, but I'm trying to say is that this is an industrial reaction. Okay, and so catalysts will not be enzymes, but usually we use in industries, the industrial catalysts are transition metals, usually. Transition metals or any metal that has variable oxidation state. The metal should have variable oxidation state, and transition metals are the ones which have variable oxidation state. You understand variable oxidation state, right?
Yes.
What is a variable oxidation state?
More than one valency.
Yes, on this. Like, you know, the metal can, the different number of electrons participate. I mean, valency is what? Valency is the number of electrons that participate in a reaction, right? So these metals sometimes, for example, if we talk about iron, let's suppose we're talking about iron. So sometimes it gives away 2 electrons and it gets a 2+ charge. And sometimes it gives away 3 electrons, so it gets a 3+ charge. And sometimes it gives only 1. So there's a variable number of electrons that can participate. So that's what we mean by variable oxidation state. Variable number of electrons participate. So it's those type of metals we need for catalyst. Why you don't need to go into details for now. In A levels, yes, you will do catalysts in detail, but not now. But just understand that it's usually transition metals, and it is because of their variable oxidation state. Because it's easy for iron to move back and forth from 2+ to 3, back and forth, reversible, back and forth. So from 2+ to 3+, and then back to 2+, and then back to 3+. And this is exactly what is required for a catalyst to do. It does not participate in a reaction, but it facilitates. And how does it facilitate? It just sits there. It attaches to the molecules, helps them to combine with each other and form the product. And then it detaches from the product, comes back and attaches to new reactant molecules. Remember how we studied the mechanism of enzymes? So these catalysts behave the same way. It's just that they are metals and they are not enzymes. Okay, so from unsaturated, we went to saturated. Okay, now, yes, one point that I forgot and now I remember is that which one, alkene or alkenes have higher melting point and boiling point, and why? Yeah, तो मैंने answer लिखा हुआ है, but you also have to tell me why. Alkanes or alkenes, which ones should have higher melting or boiling point, and why? Huh? Nobody? Guess. Look at the table in your book. Look, compare table. Yes, this is alkene table. Let me remove this. This is the alkene table. Look at their boiling points, 258. This is 258. And then you have another table for alkenes boiling point. Table 10.1 on page 255. This one, page 255, this one. So let's, if you have the book, let's compare ethene, and let's compare it with ethane. Ethane's boiling point is -87. Ethane's boiling point is -87. I'm writing it here. And ethene is -104. So which one has lower? Ethene is -104 and ethane was -87. So which one is lower?
Ethene.
Ethene, right? This is lower, right? This is lower. Okay, let's talk about propane. Propane boiling point is -42. I'm writing it here, -42. Propane is -42. Propene is -47. This is lower. Right? What about butane? Butane is 0. And butane is -6. Pentane is 36. And pentene is +30. So which has lower? Alkenes have lower, right? So why is that? Okay. I have drawn this diagram. Let's share it with you. But this diagram is not too good. It's not too good. Let me draw another one. See, remember, when you have a straight chain in alkenes, it's a straight like this. Okay? And so they can pile up on each other. Same thing. And we have already discussed, right? But when you have a double bond in a chain, what that does is it gives it a bend. Okay, it gives it a bend. For example, you have this chain and then you have double bond and then this will take a turn. If you have another double bond here, This will again take a turn. Sorry. Something like, this. Like at every point, it has a double bond. The chain will take a turn. Do you understand? So the more double bonds, the more twisted the molecule is, the more turns the molecule has, and therefore less interaction between molecules. So, I mean, they can stack and pile up this way, but these, because of their turns, they cannot pile on each other. I'll show you an unsaturated fatty acid. I'm sharing my screen, right? Huh? Screen sharing is paused. Okay, I want to share this thing with them. Let me see. Oleic acid. This is an example of an unsaturated. This is a mono unsaturated fatty acid. What do we mean by that? Mono unsaturated fatty acid, meaning it has only one double bond. Can you see my screen?
No, miss.
New, it's a resume share. And then this. And then this share, right? Can you see it now? Can you see my screen now?
Yes, miss.
Okay. Yeah. Okay, now can you see this molecule?
Yes, miss.
Yes. So, and you can also follow my mouse, right? Can you
Yes.
follow my mouse? Okay.
Yes, miss.
Yes, okay. So now look at this. Here is the double bond. And can you see the chain was going this way? And when the double bond came, it took a turn. Did you see that? Yeah. So more the bonds, more the turns. So I gave you this simple formula. I mean, I'm showing you this simple molecule with only one bend. So if more the bends, let me show you something else. Polyunsaturated. Polyunsaturated meaning a lot of double bonds. Unsaturated meaning multiple bonds, right? Polyunsaturated. Fat structure formula. Okay, let me see. Let me see if I can find something to show you guys. Yeah, look at this. This is one example, but then again, this is mono unsaturated. I want to show you something which is, yeah, here maybe, this one. Yeah, can you see? Look at this. Yeah, each double bond, it's bending. Each double bond bending. Each double bond bending. And so much so that it has turned into a circular shape like that. So you get my point, right? So the more the double bonds, the more the bending of the chain, and therefore they cannot stack on top of each other. Some of you got the point? Okay, let me get back to my original. How do you new share? Get back to. So therefore, less the interaction between the molecules, and therefore less van der Waals interaction again, and therefore lower melting and boiling point. Okay, I hope you understood. So therefore, when we convert these alkenes into alkanes, we are converting them from unsaturated to saturated. So their melting points are higher than the room temperature. So that means at room temperature, they are in the solid or at least waxy state, semi-solid or waxy state. Semi-solid meaning like, the consistency of a butter, cream, margarine. What happens? They are saturated. They become saturated or whatever. They are saturated. And so their melting points are higher than the room temperature. Therefore, they are solid at room temperature. Now, when you have polyunsaturated, you have double bonds. Examples are vegetable oil, which are liquids at room temperature because their melting points are lower than the room temperature. So before the room temperature has been achieved, they have already melted. So they are liquid at room temperature. This oleic acid that I just showed you, which has only one single bond, is found in olive oil, okay, sunflower oil, and most of the vegetable oils. Usually animal fats are saturated. Now, some of the scientists, according to their research, the saturated fats is not good for our health because sometimes their melting point is even higher than our body temperature. And so in our vessels, they exist as solids and waxy solids, which leads to atheroma formation and atherosclerosis, and therefore the heart diseases. And therefore the doctors promote and encourage these vegetable oils like olive oils and sunflower oils for our cooking, and that we should eat more of oil cooked rather than the animal fat in our diet, right? But recent research has now refuted all of this, and they say no, saturated fats are not responsible for the heart diseases, and there is no significant relation between. That's, by the way, the latest research. But still, all the scientists agree, and everybody agrees, that unsaturated fats are always the best. They are the safest. So yeah. Yes, Yusra, I saw your hand raised. Yes.
Miss, over here you have written that from unsaturated is going to saturated ethane, right? But in the book,
Yes.
it's written the unsaturated ethane is the product.
Where? Okay, let me see. Where? They have written ethane.
Yes, in top of the equation, they have written the unsaturated ethane is the product. Unsaturated, I think.
Unsaturated ethane is the product. Yes. Unsaturated, and this is saturated. Now, how can ethane? I think this is a printing mistake, right? How can ethane be unsaturated? But anyway, no, I don't think this is this should be unsaturated. Okay, this should be saturated. Saturated meaning no more atoms or no more atoms can sit in the molecule. So ethane is saturated. You're printing it. I think this is a printing mistake. Yeah, this is a typo, I think. Okay. Because you see, look at the formula. Same thing, C2H6, right? C2H6, C2H6. Okay. Okay. So that's all about hydrogenation. Let's move on to hydration. Hydration, as you guys suggested, is the addition of water molecule. Again, okay. Okay, again, I made structural formula so that we can understand better. All are in gaseous state. Okay, again, this is also not spontaneous, meaning you have to have a lot of energy. You have to give a lot of energy to break these bonds. Not only that their boiling points are also so low that they are all in gaseous state, so much so that in order for them to react, you have to pressurize them, like, squeeze them in a small volume so that they can come into contact with each other. Otherwise, they won't, because their boiling point is so low, they're so volatile that there will be no reaction if you don't squeeze them in a small area or a small volume. Also, they need a catalyst, phosphoric acid. Now, you might ask me that there is no transition metal in this catalyst. It's phosphoric 5 acid. So yeah, sometimes this group 5, sometimes these group 5 elements, they also sometimes show variability. Sometimes, not, this is not common, but sometimes they do show variability in their oxidation states. Therefore, they can also be used. Even aluminum sometimes shows. So how? Like sometimes they give away 3 electrons and at other times they accept 5 electrons. Ariba, please keep your camera off. So, you know, it's variable. Same is the case with 4. Sometimes they give away 4, sometimes they take, this is not common. It's not common in ordinary reactions, but yes, sometimes. And phosphorus, again, it has 5, right? So it either, sometimes it takes and at other times it gives away. But yes, okay. So what happens now? Now water has 2 groups, hydrogen and hydroxyl. I mean, it has 3 atoms, but this is how it is split. Now the double bond, one of the double bonds will break. Again, each carbon atom will be left behind with a lone electron, and hydrogen will go and attach to one, and hydroxyl will go and attach to the other, resulting in ethanol. Okay. Now, don't make the mistake of attaching okay, no, but remember, always remember that when you break this bond, you have one lone pair on the 2 carbon atoms that were involved in the double bond, meaning don't add the new atoms on the same carbon atom. That's what I'm saying. Don't add this new atoms on the same carbon atom, but on the 2 carbon atoms which are involved in double bond. Okay, just don't make that mistake. And then, so that is that. Let's move on, and then let's go on to alcohols. But before moving on to the alcohols, let's go through these questions real quick. What are the molecular and structural formulae? I think you know this, right? Molecular and structural formula of 1,2-dibromoethane. We discussed it, right? Right.
Yes, Miss.
Yeah, if anybody wants me to in detail explain in detail, please raise your hand. Okay. Write the word and chemical equations for the hydrogenation of ethene. We just did. They have also this here. Hydrogenation. This is the structural equation. Oh, sorry, we are asking for chemical equation. So write down the chemical equation. How? Okay, let's see if we can balance the equation. So we know ethene's formula. And, you know, for me, when I was a student, writing the chemical actual formula equation was not as easy as this was. This was really easy. Making this, drawing this was easier for me. So if it is easier for you as well, you can draw this and then just write down their formulae looking at them. So we have 2C, C2, H4 plus hydrogen giving C2H456, C2H6, C2H6, and then make sure that you are balanced, 2 carbon, 2 carbon, 6 hydrogen, 6 hydrogen. So this is the chemical equation for hydrogen of ethene, hydrogenation of ethene. What is the catalyst used in hydrogenation reactions? Yes? Anybody wants to answer?
Nickel.
Sorry?
Nickel.
Nickel, right. Okay, for hydration, they show phosphoric acid, right? For hydration. Yes, for hydration, it was phosphoric acid. Okay. Yes. Okay. Unsaturated hydrocarbons take part in addition reactions. Write a word equation for the reaction between propene and hydrogen. Write a word equation for the reaction between propene and. So let's see. Can we write? Without looking at the back. Propene. Let's. Propene plus hydrogen. Hydrogenation का ये ना? The reaction between propene and hydrogen. Okay. This is word equation. Hydrogen will give us what? What should be the product?
Propane.
Propane, right? Propane. Okay, now if they ask us to write the chemical equation, have they asked? No, write a simple equation for the reaction between butene and steam. Write a simple equation for the reaction between butene and steam. Okay, butene. Butene, let's draw butene. Drawing is easier for me. Double bond, okay? Help me out. And water. Giving. So what will be the product?
Butanol.
Very good. Very good. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, just add them with hydrogen atoms and you will have butanol on which carbon? Beta? Which carbon should I add?
First,
Huh. You can add on any of these two. Okay, you can add on any of these two. 1, 2, 3, 4. Yeah, because the double bond was here, right? So when the double bond broke, this carbon and this carbon got available. And so the OH came. Let me write OH here. Okay, so the OH came and attached here, and the other hydrogen went and attached here. You know, I can show it this way, like this. Look at this. The OH came on this carbon and the other hydrogen went to the other carbon. And so if you have butene instead of this ethene, it would be like this. So OH sat on this carbon and the other hydrogen, these are the two new atoms from water, that they came from water. Okay, so this is hydration. Okay, so yes, you will have butane. So how will we write this? What will be the name for this? Butane. 1-all. Okay, remember this is a functional group for alcohols. This is a functional group for alcohol. And so you write the parent name. Parent name is, you know, the molecule that you started with. It's called the parent name. It has 4 carbon atoms, so we will call it butane. And then this is the longest carbon chain. And we will start counting from, we will count the carbon atoms in such a way that the functional group, the carbon with the functional group should get the smallest number. Okay, so butane 1-all. I mean, we could have counted from here as well, but that would be wrong. So we will count from here because this carbon has the functional group. Okay, so butane 1-all. If the hydroxyl group, sorry, is on the second carbon, then we will write butane 2-all. Okay, so these are 2 isomers. You can call them 2 isomers of butanol. Okay. Then chloroethane is one of the chemicals manufactured from ethene. Name the compound that reacts with ethene in an addition reaction to give chloroethane. Chloroethane.
Chlorine.
Now, if you have chlorine, you should get, if you have chlorine, chloroethane, one of the chemicals, name the compound that reacts with ethene. Okay. Now, if you have ethene and you have chlorine, as you said, okay, so this will break, right? One chlorine will sit here, the other chlorine will go and sit there. So what will you get? Chlorine.
1,2-dibromine.
Yeah, so this is what we are going to get. We're going to get, no need to write 1. Yeah, no need to write 1, 2. No. Yeah, no, we should. Yes, you're right. 1,2-dichloroethane. Yes, because, you know, chlorine atoms can be on the same carbon. So yes, it is important to name. 1,2-dichloroethane. This is what we are going to get. But what they said, the product they said that we have is chloroethane, only one chlorine. Only one chlorine, rest of all are hydrogen. So what should, and they are saying what compound can react. This is not a compound. This is an element. This is not a compound. You know the difference between compound and element, right? So the question said, name the compound that reacts with ethene in an addition reaction to give chloroethane. So compound meaning composed of two different types of atoms. So can we have HCl?
HCl?
Yeah. The hydrogen will go and sit on the other, and so we can have chloroethane. Right? Okay. Draw the structural formula of chloroethane. We have done that. Chloroethane can also be made by a substitution reaction. What are the reagents and reaction conditions for this reaction? Yes, substitution is that one, that photochemical reaction in which the ultraviolet light was breaking the bonds of chlorine atoms. And so, yes, your answer that, you know, chlorine will react with ethene. This one, this is substitution reaction. Huh? Substitution. So chloroethane can also be, sorry. Substitution is on alkenes. Okay, I'm sorry. Why? Because, you know, this should be addition. That's why I got wrong. Why did I get wrong? Is because these atoms, when they will add, this will not be called substitution. This will be called addition. Substitution is that you remove an atom that is already bonded and you substitute it by some other atom. Substitution meaning something taking the place of another thing. Okay, so if you have this alkane, hydrogen atoms are already sitting. Now chlorine will come and substitute two of the hydrogen atoms. This is called substitution reaction. So substitution reaction is of alkenes. So these hydrogen atoms, these will break, okay, and chlorine atoms can come and attach. And they will do one by one atom at a time, right? So first this hydrogen, because there are no double bonds here, single bond. So first this hydrogen will be removed and this chlorine will come and take its place. And so we can have chloroethane. And you can show the chlorine anyway, down or side. Okay, so this is chloroethane. Okay, this is ethane reacting with chlorine. Also show chlorine free radicals. Free radicals is shown this way. They have shown it here. Oh, no, they did not. Okay, they did not show the free radicals here. But anyway, they have only shown chlorine. They did not show the free radicals. So simple chlorine molecule this way. Okay, then no need to do this. Chlorine molecule, that's it. And but then, you know, the question arises, where did the other chlorine go? This is not a balanced equation. So I would suggest you use this. Okay, in brackets, this is square brackets would mean free radical. Free radical, what's a free radical? Does anybody remember? What was a free radical?
It is the atom.
Yeah, it is a, yes, you are correct. Yes, it is an
Atom.
yes, it is an atom. It is not an ion, unbonded atom, meaning that this chlorine, because it is from 7th group, it will have 7 electrons in its shell, not a chloride, not a chlorine molecule, but a chlorine atom. Sorry. 2 hydrocarbons and 2 chloroethane. Oh, Sundar is saying we can avoid writing this by adding another ethane and then showing this other chlorine atom on the other. Well, yes, you can do that. You can do that. Okay. Okay. Is there any question? Are you guys
No,
with
ma'am.
me? Or are you guys confused? Is there any question? Please ask.
No, miss.
Okay. What are the reagents and reaction conditions for this reactions? So what are the reagents for this substitution, photochemical reaction? Who remembers?
There should be the presence of light.
Very good. Yes. There should be light, ultraviolet light or sunlight available, and reagents. There should be chlorine, right? Reagent meaning reactant. So there should be chlorine, and let's see, I am looking at their answers. Yes, ethane and chlorine are the 2 reactants in sunlight, ultraviolet light. Okay. So also mention ethane, because of course we need ethane and chlorine. So look at this formula, look at this equation and then answer the question. So this bond, for breaking, it requires ultraviolet light. Okay, and then you need, this is the one reactant, ethane, you require chlorine, you require ethane, and you require ultraviolet light. These are the 3 conditions. Okay, let's move on to alcohol. Okay, alcohol is another homologous series, which has OH as its functional group. Okay, and the end name, the suffix of its names is -ol. They're also called alkanols. Okay, and all the alcohols have the OH group. Okay, these are the first 3 members of the family. Methanol, because it has 1 carbon, ethanol, because it has 2 carbon atoms, propanol, because it has 3 carbon atoms. Okay, and when we write its molecular formula, this is how we write. We separate the OH at the end. You can, I mean, by the way, write it even this, that won't be marked wrong, because there are 4 hydrogen atoms, right? So CH4O, you can write it like that. But then this writing this way does not help you in recognizing that this is an alcohol, because this can be something else. This can be a carbohydrate. This can be an aldehyde. This can be a couple of other homologous series. So this is helpful. This shows that there is OH, and so this must be alcohol. So it's easier. Okay, C2H, this is more common. C3H7OH. So we can easily say that this is an alcohol. So looking at their molecular formula, can you come up with its general formula? So what's the pattern here? 1 and 3, 2 and 5, 3 and 7. So double this number and then add 1. 3 2s are 6 plus 1 7. 2 2s are 4 plus 1 5. 1 2s are 2 plus 1 3. So the general formula is NCNH2N plus 1 OH. Okay. Alcohols do not conduct electricity. What does that tell you about their structure? If they don't conduct electricity, yes.
They don't have the decolized electrons.
Very good. Yes, they don't have any charge, meaning they are non-polar. What did you say? Delocalized electrons?
Yes, miss.
Okay. Beta, delocalized electrons are only found in metals, only and only. Okay, so what you will say is that it means that the molecules are non-polar. They have no separation of charges. Okay, and they are neutral. Again, neutral meaning same thing, non-polar, and they are colorless liquids. Okay, they are colorless liquids till carbon 5, till pentanol. Then Beyond that, I don't know, I'm not sure. You cannot say. Okay, making of ethanol. Now, making of ethanol is the same as the hydration of ethene that we just discussed. Hydration of ethene, remember? We were making ethanol. We were hydrating the ethene, making it react with water to give us ethanol. So this is done industrially at 300 degrees Celsius at a temperature at a pressure of 60 atmosphere. And so this is how it is industrially done. Okay. But another way of doing it is there are two ways of making ethanol. Another way is fermentation. Okay, why do we make ethanol, by the way? It is a good organic solvent. Okay, what did we discuss about organic organic solvents? What makes a good organic solvent? Why do we need organic solvents? Remember? I discussed in my last class. Why do we need organic solvents? Remember in dry cleaning agents, they dry quickly, but as a solvent, what's a solvent? Okay, what is the definition of solvent? Tell me. Yes, solvent is something that dissolves the solute. Yes. Organic solvent is when you want to dissolve something organic, when you want to dissolve something non-polar. So of course, non-polar substances will dissolve in non-polar substances and polar dissolve in polar. Remember, we did this. So especially when we are trying to wash greasy stains, or when we are trying to wash like in dry cleaning, we want sometimes we want the non-polar substances to be washed away. And so we want something that will dissolve that grease, that will dissolve that non-polar grease. And for that, we need organic solvent. Okay, and but then again, we also want, if it can dry up, if it's volatile and it can dry up on its own, like in dry cleaning, well and good, we won't have to wash. But then if we want to wash, then it should be polar enough to get washed away as well. That's called an organic solvent without the use of soap. Okay, so so alcohol makes a good organic solvent. Why? Because it is non-polar, yes, but it has little polarity. Remember, I told you haloalkanes. Haloalkenes were also the same thing when we were discussing haloalkanes. What were haloalkanes? Haloalkanes. Hello is for halogens. Alkanes. Halogens on alkanes. Haloalkanes. So they were also good organic solvents because of the same thing. They were non-polar. I mean, we want in the middle. You want something which can dissolve polar and non-polar. So something which is not absolutely non-polar and something which is not absolutely polar. So something in the middle. So they also make good organic solvents. Why? Because look at this. The whole of the molecule is predominantly non-polar, except for this polar tail because of the oxygen. Remember, oxygen is one of the top 3 electronegative elements in the whole periodic table. So it pulls the electron cloud more towards itself, which gives all the molecules this partial, very partial. I mean, I'm not going to even write. It is so partial that it's not enough to conduct electricity. Okay, by the way, pure water also does not conduct electricity. Pure water. Okay, so that's why it is used in organic solvents. Okay. Another thing, alcohol is also going to have hydrogen bonds. What were hydrogen bonds? Does anybody remember? I discussed in my in my class, in my first class of organic chemistry? Nobody remembers, right?
The van der Waals forces between the positive and the negative.
Hydrogen bonds are not van der Waals forces. In fact, I told you that intermolecular forces of the intermolecular, there are two types of intermolecular forces, van der Waals and hydrogen. And van der Waals were really weak. They are very weak because they are only dependent upon temporary polarity, temporary dipole of the molecules. But hydrogen bonds, they are very strong, not very strong. Of the intermolecular forces, they are stronger. They're stronger than van der Waals. Whenever hydrogen is bonded to fluorine, oxygen, nitrogen, one of these. Whenever hydrogen is directly bonded to any of these three, that's when you have hydrogen bonds. Remember that. And hydrogen bonds are stronger intermolecular forces. They give them higher melting and boiling points. Responsible for higher melting and boiling point. That's why alcohol is a liquid. It's not a gas. It's liquid at room temperature. Okay. It is volatile. Its boiling point is not that high. It's not higher than water. Its boiling point is a little above room temperature, like around 75 or 60, something like that. So it is volatile, but it is not as low as the other alkanes and alkenes. It's not as low as the alkanes and the alkenes or the other hydrocarbons. Okay, and that's because of the hydrogen bond. That's because of the hydrogen bond. Okay. So natural, so this is industrial that I just showed you, hydration of ethene. And now this is the natural production of ethanol. Natural meaning within the organisms. So, okay, without looking, real quick revision. What is fermentation? Answers to sare likhe hain. Okay, but still, who remembers what fermentation is?
The anaerobic respiration.
Okay, good. And so tell me a little about anaerobic respiration.
It is
What
the
is it?
respiration without the oxygen.
Yes, without oxygen. Very good. And beta जोर से बोल दो, please. Please, loudly.
It makes ethanol usually.
It makes alcohol. Okay, product is alcohol. And is there any other product?
Carbon
Is that it?
dioxide.
Carbon dioxide. Okay. Okay. And so where do you see this fermentation? Where does it take place? In yeast. Yeast is a fungus, remember. Single cell fungus, yeast. Sorry, let me remove this. Yes. Okay. So in biological setup, the catalysts are
Enzymes.
enzymes. And enzymes are what sort of molecule are enzymes? Proteins. Good job.
Proteins.
Very good. So, and they are sensitive to,
High temperature.
very good, pH, temperature, right? Both. So keep these things in mind. Okay, keep these points in mind. And so the optimum temperature for most of the biological enzymes is
37 degrees Celsius.
right, which is around our body temperature, right? So keep these points in mind. Okay, so what your book says is that in yeast, the fermentation is self-limiting. Self-limiting, what does self-limiting mean? What does self-limiting mean? The fermentation is self-limiting.
The process ends on its own. We don't have to do anything.
Very good. Yes. Yes. Very good. Yes, yes, you got it. So the product is ethanol. So as the concentration rises, it is toxic for yeast. And when the concentration reaches 14%, there are two things that happen. First of all, the cell dies and also the sugar runs out. What do you mean sugar? Glucose. Okay, let's write a balanced chemical equation for fermentation. So fermentation is, yeah, you said anaerobic respiration, and anaerobic respiration's reactant is, what's the reactant? What molecule do we start with?
Glucose.
Very good, glucose, very good. So what is the formula for glucose without looking at the book? Does anybody remember?
H12O6.
Very good, C6H12O6. It's worth remembering. Okay, remember the formula for glucose. Okay, so we won't write any oxygen because this is anaerobic, so no oxygen. Okay, what are the products? We know ethanol, right? What's the formula for ethanol?
C2H5OH.
If anybody doesn't remember, make this. This is what I do. Real quick on one side, make this. Don't put in the hydrogen if you don't want. If you're running out of time, just C2H5OH. C2H5OH. And is there any other product?
Carbon
Energy.
dioxide.
CO2.
Yes, energy is released, that's right, but energy cannot be called as a product. Okay, energy cannot be called a product. Can it be called a product? Well, I don't know. Okay, but the other product I think is water, if I'm not mistaken. Correct me if I'm wrong.
Mrs. Carbon dioxide.
Carbon dioxide, okay. Yes, okay, so we have carbon dioxide. Yes. Now let's balance it. Are we balanced? 1, 2, 3. No. Okay. Now the thing is that choose an atom which is only in one product. So carbon is in both of them, oxygen is in both of them, hydrogen is only here because I have only one reactant. Okay, so whatever number I can only change whatever number I will change, all three will change. So I should first make sure if the hydrogen is balanced. Okay, how many hydrogen do I have here? 6 and 12 here. So that means how can I balance hydrogen? By adding 2 here, right? 2, 6 are 12. 2, 6 are 12. So now hydrogen is balanced. What about carbon? 2 2s are 4, 5. No. An oxygen are 4. Okay. Now, what if I shouldn't add anything here because this is already more in number. I should add here. So 2 2s are 4, 5, 6. So now we have 6 carbon atoms. Okay, 12 hydrogen and 2 2s are 4, 5, 6. 6 oxygen. Did you understand some of this? 11 hydrogen nahi hai. 2 6 6 6 2s are 12. Okay, you have 12 hydrogen. Okay. Now let's discuss this setup. This is the industrial setup in which this hydration takes place. Sorry, fermentation. I'm sorry. This fermentation takes place. So now tell me, what is the purpose of this? Airlock containing water. So we understand this. This is a glucose solution with yeast. But what is the purpose of this? Airlock containing water. Does anybody know? What is the purpose of this airlock containing water?
So that CO2 can escape.
Okay, good. Is that it?
And no other bacteria or microorganisms enter the solution.
Very good, Sundar. Yes, you are also correct. Who is this speaking? Ajwa.
Ajwa.
Yeah, okay. Yes, Ajwa, you are absolutely correct. Yes, we don't want, especially, you know, in the atmosphere, you will have aerobic bacteria because aerobic, they require oxygen, so they must be in the air. We don't want those aerobic bacteria here. And then also, we don't want any oxygen because we want fermentation to go on. So we don't want any oxygen to disturb the fermentation. And yes, we also want a way, escape for a carbon dioxide, right? Okay, now, real quick, tell me, of the two methods that we have studied, which one is more eco-friendly? Eco-friendly, you understand? Environmental friendly or environment safe for the environment? Which one? Ethanol, by the hydration of ethene, it originates from a non-renewable resource, which is petroleum. Okay, ethene comes from petroleum. Whereas ethanol by fermentation is made from readily renewable resource, which is a glucose. Glucose can come from sugarcane. It is usually used from sugarcane and fungus, and these are easily available. Petroleum is expensive, right? Small scale equipment capable of withstanding pressure, relatively simple, large vessels. Because remember that, what is that? What was it? Yeah, hydration. The hydration of alkene requires high temperature and 60 atmosphere, 300 degrees Celsius and 60 atmosphere. So that requires energy. That's energy consuming. You will be using electricity, we'll be using pressure. So yes, this is relatively simple, economical, right? That's a continuous process, it's a batch process, meaning, remember, enzymes reach their saturation and then you have to get back and, you know, wait for the enzymes to be renewed, to detach. And so all of that process, so it's a slow, this process is a slow, whereas this is fast. And overall, this produces highly pure ethanol, because in hydration, we don't have any other product, only pure ethanol is produced. Whereas in fermentation, we have carbon dioxide also being produced along with it. So now separation will be a job to do. Okay, it has two products. So we'll have to separate. So if you want pure ethanol, you will have to get rid of carbon dioxide. So that's a problem. So every method has its advantages and disadvantages. So it depends upon what resources are available with you and what are the, do you want pure ethanol or are you okay with carbon dioxide? So it all depends upon what you are using. Why do you want the ethanol? Okay. Okay. So which one do you think is eco-friendly of the two? So this, after going through this table. Come on, hurry up, hurry up, hurry up. We're running out of time. Huh? Fermentation, yes. Renewable resource. This is more eco-friendly. The only problem with it is that somebody might say that it is producing carbon dioxide, and carbon dioxide is it is the greenhouse gas, right? So, but they have mentioned in the book that this carbon dioxide is then used again. It is used again by photosynthesis to make glucose. So it stays within the system. And so they call it carbon neutral. This is carbon, they have used the word carbon neutral. When used as a fuel, ethanol produced in this way is potentially carbon neutral. The carbon dioxide released during fermentation and by burning the fuel is balanced by that absorbed from the atmosphere by the crop. This is photosynthesis. Usually sugar cane as it grows. Okay. So, okay. Name the first three members of the alcohol homologous series. We have done that, right? Write the word and chemical equations for the hydration of ethene by steam. This is the same as this ethene. Remember that hydration equation? This one. This is what they're asking for. Okay, so you can just write down their name, ethene plus water plus it gives us ethanol. That will be the word equation. What are the essentials needed for the production of ethanol by fermentation? What are the, you can say what material is required? So you need glucose, very good. You need yeast, okay. Yeah, closed container. Yes, and the temperature should be?
Room temperature.
Yes, room temperature. And is there anything else? I'm checking yeast, carbohydrate source, and yes, water. Okay. Yes, water. It has to be a solution, glucose solution. Okay. These are not gases. Okay. So far, only carbon dioxide is the gas. These two are both aqueous. So you also need water. It has to be in the solution form. Okay. Then what's the next question? Ethanol can be made by the addition of water to ethene. Ethanol can also be made by the fermentation of sugars using the apparatus shown here. Name the gas produced during the fermentation shown above. Easy.
Carbon
Come on.
dioxide.
Carbon
Yes, very
dioxide.
good. Carbon dioxide. Yes. This gas escapes through the piece of apparatus labeled A. What is the main purpose of this piece of apparatus? We just discussed, right? Ajwa?
So carbon dioxide can escape and none of the bacteria can enter.
Yeah, no aerobic bacteria and no oxygen. Also say that, no oxygen. Okay, remember that. C, what must be added to a sugar solution to make it ferment? Yeast. Good job. D, yes. At about, and also there's another bacteria that causes fermentation, but okay, we'll do that later. At about what temperature does fermentation take place at its fastest rate? 37. Very good. Explain your choice of temperature given in D.
The enzymes get denatured at a higher temperature and the rate decreases at a lower temperature.
Very good job. Good job. Perfect. 10.42. Methanol and ethanol are members of a homologous series. Draw the molecular structures of methanol and ethanol. I think you guys know this, right? Explain what the term
Yes.
homologous. Yes. Explain what the term homologous series means.
A group of hydrocarbons with same chemical properties, physical properties, and the same general form.
Yes, but yes. What are the names and structures of the two isomers of propanol? So you have 3 carbons, right? So just shift the position of OH, the functional group. In one
Propane
isomer.
1, all, and 2. Propane.
Yes, yes. And then just shift the position of the OH. And so we are done, okay, with these questions. So we are running out of time. So we'll do this in the next class. In the next class, inshallah, I will try to finish this chapter. Inshallah, with the help of Allah. So alcohol and esters. And then, yes, the end of chapter questions, okay? Is there any question?
No, miss.
Okay, good, good. Okay, then see you day after tomorrow, inshallah. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.
Allah Hafiz.
Thank you, Miss Allah.
Allah Hafiz.